We humans experience the world in three spatial dimensions: length, width, and height. Time adds a fourth dimension, giving us space-time. This framework, however, might be just the tip of the iceberg. Could there be more hidden dimensions beyond our perception? Imagine a vast, unseen landscape where reality unfolds in ways we can barely fathom. This is the realm of higher dimensions, a frontier that has captivated physicists and mathematicians for decades. The idea of extra dimensions is not just a science fiction trope, it emerges from serious scientific inquiry, pushing the boundaries of our understanding of the universe. Theories like string theory, a prominent contender for a unified theory of everything, posit the existence of extra spatial dimensions curled up and hidden from our view. These dimensions, though invisible to us, might hold the key to some of the most profound mysteries of the cosmos. Think about ants crawling on a garden hose. From their perspective, the hose appears as a one-dimensional line. They can only move forward or backward. They're unaware of the hose's circular cross-section, the second dimension. Similarly, we may be blind to dimensions beyond our three spatial dimensions, much like the ants are oblivious to the hose's curvature. The quest to understand these hidden dimensions is a journey into the unknown. It involves grappling with abstract concepts and pushing the limits of our imagination. But the potential rewards are enormous, offering a glimpse into the fundamental nature of reality and the possibility of unlocking unimaginable technological advancements. String theory, a leading candidate for a theory of everything, proposes that the fundamental building blocks of the universe are not point-like particles but tiny vibrating strings. These strings, far smaller than anything we can currently observe, vibrate at different frequencies, giving rise to the diverse particles and forces that make up our world. String theory elegantly attempts to reconcile quantum mechanics governing the microscopic world with general relativity describing gravity and the large-scale structure of the universe. The catch: string theory requires the existence of extra spatial dimensions beyond our familiar three for its equations to hold true. These extra dimensions, physicists believe, are curled up or compactified at incredibly small scales, far below the reach of our most powerful microscopes. The way these dimensions are curled and intertwined could determine the fundamental properties of particles and forces shaping the very fabric of our universe. Imagine a tiny, tightly wound ball of yarn. From a distance, it appears as a point. However, on closer inspection, you discover its intricate structure and multidimensional nature. Similarly, the extra dimensions proposed by string theory might be hidden from our view due to their incredibly small scale, but they could be the key to understanding the deeper structure of reality. String theory is not without its critics. Some argue that it is too abstract and lacks experimental verification. However, its potential to unify physics and explain the origins of the universe has captivated many physicists. The quest to find evidence of extra dimensions, either directly or through their subtle effects on our observable world, is a driving force in modern physics research. The concept of infinite dimensions takes us into the realm of abstract mathematics, where the familiar rules of geometry no longer apply. In an infinite dimensional space, distances and shapes behave in counterintuitive ways. Points that seem infinitely far apart in our three-dimensional world might be surprisingly close in a higher dimensional space. The very notion of distance and volume becomes fluid and challenging to grasp. One way to visualize infinite dimensions is to think of a sequence of ever-growing spaces. A line representing one dimension can be extended into a plane representing two dimensions. The plane, in turn, can be extended into a three-dimensional cube, and so on. As we add more dimensions, the complexity of the space grows exponentially, eventually reaching a point where our intuition fails us. Consider a line segment representing a finite one-dimensional space. Now imagine adding an infinite number of perpendicular lines to each point on that segment. This creates a two-dimensional plane, but one with an infinite number of lines. As we continue adding dimensions in this way, the complexity of the space explodes, leading to a realm where our traditional geometric intuitions no longer hold. Exploring infinite dimensional spaces requires sophisticated mathematical tools, such as Hilbert spaces. These mathematical structures provide a framework for understanding and manipulating infinite dimensional data, allowing us to make sense of the seemingly paradoxical properties of these spaces. While challenging, the mathematics of infinite dimensions offers a powerful lens through which to explore the fundamental nature of reality and the potential for unlocking new scientific frontiers. Unlocking the potential technological and scientific leaps. Accessing and manipulating extra dimensions, if achieved, would revolutionize science and technology. Imagine harnessing the power of higher dimensional space to create new forms of energy, manipulate gravity, or develop communication technologies beyond our wildest dreams. The possibilities are as limitless as the dimensions themselves. The ability to manipulate extra dimensions could lead to breakthroughs in energy production. Imagine tapping into the vast energy density of the vacuum, often referred to as zero-point energy, by accessing higher dimensional spaces. This could potentially solve our energy crisis and provide a clean, sustainable source of energy for future generations. In the realm of communication, accessing extra dimensions could enable the development of faster-than-light communication technologies. By sending signals through higher dimensional shortcuts, we could potentially communicate with distant stars and galaxies in real time, opening up a new era of interstellar exploration and communication. The impact on medicine could be equally profound. Imagine using higher dimensional imaging techniques to gain a more complete understanding of the human body, leading to new diagnostic tools and treatment methods. We could potentially develop therapies that manipulate the fabric of space-time at a microscopic level, targeting diseases with unprecedented precision. The human factor. Ethical and philosophical dimensions of exploration. The prospect of accessing extra dimensions raises profound ethical and philosophical questions. How would such power affect humanity? Would we use it wisely? Or would we repeat the mistakes of the past, exploiting new frontiers for personal gain or destructive purposes? The responsibility that comes with such knowledge is immense. The ability to manipulate higher dimensional space could give us unprecedented control over the fundamental forces of nature. This power could be used for good, such as solving global challenges like climate change or eradicating diseases. However, it could also be misused, potentially leading to new forms of weaponry or environmental destruction. Accessing extra dimensions also challenges our understanding of ourselves and our place in the universe. If our reality is just a slice of a much larger, multidimensional cosmos, what does that say about our significance? Does it diminish our importance, or does it expand our horizons, revealing a universe of unimaginable grandeur and complexity? The exploration of extra dimensions is not just a scientific endeavor, it's a philosophical journey. It forces us to confront our preconceptions about reality, our place in the cosmos, and the ethical implications of wielding such profound knowledge. The answers to these questions will shape the future of humanity as we venture into the uncharted territories of higher dimensional space. A universe of infinite possibilities. The concept of infinite dimensions is a mind-boggling journey into the unknown. It challenges our perception of reality, pushing the boundaries of science and imagination. While the existence of extra dimensions remains a theoretical concept, the pursuit of this knowledge has already yielded profound insights into the nature of the universe. String theory, with its elegant framework and potential for unification, has revolutionized our understanding of physics. The mathematical exploration of infinite dimensional spaces has opened up new avenues of inquiry, revealing the intricate and often counterintuitive properties of these realms.